Good day, colleagues. Welcome back. This is Learn Extra Teacher Talk, and our focus today is on physical sciences. And today I have the privilege of interviewing Angela Stott from UCT, and we're going to be talking about some research she's done about a case study involving a particular learner. And from that, we're going to extract some ideas about belief systems and learning. So, Angela, welcome again.
Thank you.
It's good to have you here. Please, won't you tell me about this interesting case study and what it involved?
Yes, now this was about a very intelligent boy who I've actually known since he was a baby. Now I'll use a pseudonym, and the pseudonym that his family chose was Andre. So I came across Andre, as I said, even before he was at school, but then I started teaching him in preschool. And I realized this is an exceptional child. And just after that, I started teaching high school. And since we had a bit of a link from when I was teaching in preschool, we kept in contact. And he would sometimes come to my lab while I was preparing my lessons for my science high school lesson. And maybe I was doing a demonstration or so. And then he'd chat with me about what I was doing. And it became very clear that he was extremely intelligent and he learned really effectively. And so as time went by, I had more and more to do with him because he got involved in the Expo for Young Scientists, and I mentored that. And I realized that he must be extremely bored in class. So I arranged that for his high school years, I would give up my free periods, and in that time I would teach him on an enriched and accelerated program. So we readjusted the program, the timetable. The school was very accommodating. And so I taught him individually, came out of the class. So I thought, this is actually an amazing experience. I've got to make the most of it. So I wrote reports after just about every lesson of what I observed, what I did, what he did, and my reflections on what was going on in his mind and how I was affecting things and so on. I recorded a lot of the lessons and I interviewed him and his family members and so on to try and understand, how does a good learner learn? With the hope, of course, that will help other learners who aren't naturally so good to learn better.
Just give us again the context for this. This wasn't in an affluent, well-resourced community.
No.
It was in a rural
right.
environment.
Yes.
And so we have these learners that we're teaching and engaging with, but they are exceptional. So can you tell us a little bit about the learning process and examples of how Andre went about his learning?
Definitely. So I think to make it concrete, I've chosen out three particular incidents of how he learned, and then I'll describe that, and then we can try and extract from that something that might help others. Just first of all, this sort of belongs to the category of expert novice research, where we study an expert in action. And from that, we hope to get information that can help a novice to improve. So although, yes, partly what I say now can help teachers who have exceptional learners inside their classroom, how to stimulate them, because they're often very bored, and so they don't reach their true potential. But even just with the more normal learners or even the weaker learners, what it did to me was it made me realize that learning is difficult even for the clever. So how much more for those that aren't so? And so one must understand that so that you as a teacher can teach accordingly, because we tend to think learning is just like by internet transfer. It's just such an easy process, and it's not.
Right.
Yeah. Okay, so I'll go through these three examples, and then afterwards we can sort of extract some principles.
So you did mention about novice and expert, and
yes.
Novice being, in this case, the average student, and the expert is the case study
yes.
that we're looking
and obviously there are limitations to this kind of research because experts and novices are not the same. So obviously I do realize that a more normal child is not like Andre in his abilities and whatever, or her abilities, whatever. But still, there are things we can learn from those who are better at learning, and in that way help others that are less good.
So
yes, so this is the first example that I want to illustrate. This is a teaching of the formula F equals MA. Now, I first showed Andre this formula when he was in grade 8, and he clearly hadn't come across it before. So what happened was, I showed it to him. I said, okay, so let's start discussing this. So he looked at it and he said, oh, that's an interesting formula. What is it telling us about? Oh, he undergoes a dialogue with himself, and every now and again he actually wants me to answer. It's about force, mass, and acceleration. Oh, let me think about this. How are these related? Now, obviously, each of these concepts he had already mastered, the individual concepts. So now he was focusing on the relationship between them. And so he said, okay, how can I make an object accelerate at a greater rate? Obviously, I must push it harder. Oh, so that means that force is directly proportional to acceleration. What about mass? And he thinks, okay, if I have two objects with different masses and I apply the same force, how will their acceleration differ? Oh, the object which is more massive will accelerate at a lower rate. This takes about 20 minutes. He's busy writing all the time and long pauses in between, busy thinking it through. Eventually derives that formula. Actually, he prefers it in the equation, in the format A equals F over M, because it just fits with the proportional relationships more. But anyway, so he derives that formula. Good. Next day, I think this is a clever child. We've dealt with the concept. He's got that clear in his mind. Now we move on. Let's plug some numbers in. Gave him a question where, just a standard kind of question where you must put in the variables and you must solve for the unknown. No, he doesn't just, like you would think maybe a child would do, write the formula down and then substitute. Not at all. He says, oh, this is force, mass, and acceleration. How are those related? The formula is sitting right in front of him. I even point to it. It's as if he's got, something in front of his eyes. He can't see what I'm pointing at. He can't hear me because his mind is busy going, what's the relationship between F, M, and A? And he derives it from first principles over again. Takes another 20 minutes, just like he did the day before. In other words, he still needs to grapple with it, even though yesterday it seemed like he'd got it. And then eventually he gets the formula. Oh, that's the formula. And then he realized, oh, it's written right there, which is what I'd pointed out before. The next day, the same story. For a year, he would not write that formula down just like that. He'd derive it from first principles.
That's
Obviously, it got faster and faster. But still, even within that entire year, it was slow enough for it to be noticeable that he was actually doing it from first principles. After about a year, then I saw him just writing it. So I asked, oh, okay, so now are you just recalling it? And he looked at me as if I'm crazy. I never recall an equation, he says. I always work it out from its meaning. Because what's the use of recalling an equation? But if you work it out from its meaning, then it makes sense to you. It's just that he could do that working out so fast that it looked like he was just writing down.
That's amazing.
Okay, next example. Here I was busy teaching him about the relationship between the length of a pendulum and its frequency. So I said to him, okay, the length of a pendulum affects its frequency. He stopped me and said, I don't know if that's right. Let me check if that's right. Is it really the length of the pendulum that affects the frequency? He drew these diagrams. He said, these two pendulums, they differ significantly from one another in their lengths. The second one is significantly longer. But I'm sure that they will vibrate at approximately the same frequency as one another. So it isn't length of pendulum that's the issue. It's length to center of mass that's the issue, which is perfectly correct.
That's absolutely right.
Yeah.
How old was he at this time?
I think that was also grade 8, actually. Yeah.
Very insightful, isn't it? But it's just that spark of almost genius.
Oh, indeed.
Yeah.
He is a genius. Next example. I was teaching him about lenses. Now, in the section of lenses, you make them draw ray diagrams with the object at various positions.
Yes.
At beyond F and beyond 2F and then at 2F and so on. And then you see, where does the image get formed? Is it a virtual image? Is it upright? Is it diminished? Whatever, and where? So we went through the whole process. I got him to draw the ray diagrams for each of the situations. End of the lesson. I want to recap. So I say to him, now I want you to explain back to me everything we've gone through. And he looks at me and says, that's too much. He doesn't like speaking very much. So he said, no, please can I do that in the form of a graph? And he drew this graph which summarized what we were learning, but in a diagrammatic form rather than the word form which I had thought that he would answer me in. Yes. So these three, they're just three examples that I've picked out, but I want to use them to illustrate some general strategies that I, from the 3 years that I observed him, extracted, and also belief systems that drove his learning, which I think can also be taught to learners that are less capable to improve their learning.
I mean, this is a unique graph. I mean, I've been teaching for a number of years, and would never even think to draw a graph like that.
Indeed.
And it's absolutely correct. Yeah. So for a learner to give you an answer in this graphic form does show that he's somebody exceptional.
Yes.
But at the same time, having said that, we don't just want to say, well, he's exceptional, but the real question and the reason for our discussion is what can we learn about his ways of learning?
Yes.
And how can that help teachers and other learners?
Exactly.
Okay, so I think what we're going to do, I'm fascinated by Andre and his way of thinking, but I think what we'll do is we'll just take a short pause at that point, having looked at those examples, and then after we come back, let's see how we can apply some of these strategies to our teaching. Okay, so please join us as when we after the break, but we're going to go to a short break, and after that we'll get into some practical strategies that we can extract from this case study that will be useful and relevant for putting into practice in our classrooms. So we'll see you after the break.